Now let us discuss the 131 question. Match the following. In this type of match the following questions, we use the method elimination. Elimination is the best method to answer the matching type of questions. You need to know the all the oxides nature. You just pick up the one of oxide and firstly solving the given question. Here are the some points to remember. The first point is metal oxides. Metal oxides which are in basic nature. We have to remember that metals oxides which are in its nature is basic nature. Second point, non metal oxides are in acidic nature. Okay, metal oxides are basic in nature and non-metal oxides are acidic in nature. Okay, now let us verify the question. Here, randomly I choose the barium oxide. Here, barium oxide. We know that barium oxide belongs to group 2 element. So, it is a metal. Here, just now you discussed that metal oxides which are in basic nature. Here, base 2 group 2 element. That's why this metal oxide which are in basic in nature. Okay, B is matches with 1. B is 1. Here B is 2. You can eliminate the option 1. Here B is 4. Option 3 also eliminated. Here B is 3. You can also eliminate option 4. Only remaining option you have is option 2 is the correct answer. Now let us check the remaining options also. Okay. We know that a carbon monoxide which is in neutral in nature. That means A is 2. Right. Okay. Satisfies. We know that from the intermediate posterior question that why Al2O3 is an amphoteric in nature. That's why Al2 is its nature is amphoteric. Why? Because it reacts with acids and bases. That's why Al2 aluminum oxide is called as an amphoteric in nature. That's why Al2 is matches with Al2O3 is matches with 4. That is amphoteric. Here C is equal to 4. In this option C is also satisfied. Now let us come to the option D. Here Cl2O3. Cl is a non-metal. We know that non-metals are acidic in nature. That's why Cl2O3 matches with acidic. Here D also satisfies the given condition. So option 2 is the correct answer. By using of elimination method, you can easily answer the matching questions. Now let us discuss 132 question. The rate constant for first order reaction is, okay, the time required to reduce 2.0 gram of reactant to 0.2 gram. Here what they given that the rate constant for first order reaction, rate constant is equal to 4.606 into 10 power minus 3 second inverse. Okay, and time, here they asking that how much is time required to reduce 2.0 gram to 0.2 gram. We know that from first order reaction rate constant equal to 2.303 by T into log of R naught initial by final. Okay, here you have to find out time. Then we write the equation to T equal to 2.303 by K into log of R naught initial by final. Then substitute the above values. T equal to 2.303 by, here K, the rate constant value is 4.606 into 10 power minus 3 into log of, here initial concentration is 2.0 by final concentration is 0.2. You can simplify. T is equal to 2.303 by 4.606 into 10 cube into log of 2 by 0.2. Now multiply 10 on both sides. 10 by 10 you will get time is equal to 2.303 by 4.606 into 10 cube. Here log of 20 by 2. 20 by 2 becomes 1. You know that log 10 is equal to 1. Then t is equal to this value, whole value equal to 1. Then time is equal to 3.30 by 4.606 into 10 cube. Here minus 3 present in division, it will comes to the numerator side, it becomes positive. 2.303 by 4.606, that gives rise to 1 by 2. Rewrite the equation in t is equal to 1 by 2 into 10 power 3 second. Here t is equal to 0.5. 1 by 2 equal to 0.5 into 10 cube second. Here t is equal to 0.5 into 1000. It gives rise to 500 seconds. So our answer is C is our 3 is our correct answer. Now let us discuss the 133 question. An alkane on ozonolysis gives methanol as one of the product. Its structure is okay. First of all, now let us try to write the structure of ethanol. Ethanol means bond, C double bond O bond hydrogen. Here they are asking that among the 4 options, which compound on ozonolysis gives the methanol as one of the product? Here I am explaining simple trick for ozonolysis on alkene, that move the double bond and add oxygen on both sides. Then it becomes bond C double bond O bond oxygen plus C double bond O bond hydrogen bond CH3. You simply remove the double bond and to add oxygens on both sides. It will become this one. This is hexanaldehyde and this is 1, 2. This is an ethanol. Okay. Methanol is not produced by ozonolysis of first compound. Now let us verify the third option. Here bond CH2 bond CH double bond CH2. You can simply remove the double bond and add oxygens on both sides. You will get CH2 bond C double bond O bond hydrogen plus here hydrogen bond C double bond O bond H. Here this product is called the methanol. So compound 3 produces the methanol on ozonolysis. So our answer is 3 is our correct answer. Remaining 2 options, verify the remaining 2 options what products are produced. Now let us see the 134 question. Which of the following alkane can't be made in good yield by Wurtz reaction? By using a Wurtz reaction among the 4 options, which can't be prepared? Which alkane can't be prepared? Okay. Now let us try to understand what you meant by Wurtz reaction. Wurtz reaction means when 2 moles of alkyl halide react with 2 moles of sodium to give alkane plus 2 moles of sodium chloride. By using a Wurtz reaction, you can produce the even number of carbons only. Does not form the odd number of carbons. That means here producing of 2, 4, 6, 8, etc. This type of compounds are produced. Now let us verify the given options. N-hexane. N-hexane here 6 carbons are present. This is a even. This can be produced by Wurtz reaction. Now let us look into the reaction. CH3 bond CH2, CH2, Cl plus 2 moles of sodium. Here 2 moles of CH3, CH2, CH2 bond Cl plus 2 moles of sodium to gives rise to CH3, CH2, 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 CH3 plus 2 moles of sodium chloride. Here N-hexane is produced. Here how many number of carbons are present here? Number of carbons are 6. 6 is an even number. Here butane. Butane, that means 4 carbons, even number. Here N-butane also containing 4 carbons, which is an even number, which will be produced by using a Wurtz reaction. But option 3, it have the odd number of carbons. That means it has 7 carbons. 7 carbons is not produced by Wurtz reaction. So our answer is 3 is our correct answer. Now let us discuss 135. Anisole on cleavage with HI gives rise to. Okay. Now let us see the mechanism. Anisole. First of all, write the structure of anisole. Anisole means benzene bond O bond CH3. Anisole is also called as methoxybenzene. This will react with HI. Here oxygen containing 2 lone pair of electrons which attack on hydrogen, and this iodine is removed as H minus to get bond oxygen, bond hydrogen, bond CH3, positive charge, and having 2 lone pair of electrons. Here the bond between benzene and oxygen does not dissociate. Why? Because benzene having the positive charge is unstable. That's why the bond between oxygen and CH3 group is form phenol bond OH plus CH3 positive and H minus to form methyl iodide CH3 ion. Now let us verify the given options. Phenol plus methyl iodide. Here phenol plus methyl iodide. So option A is the correct answer. Now let us verify the 136 question. For which one of the following Bohr model is not valid? We know that Bohr's model is valid only for singly bonded electron. That means which species having only one electron, then Bohr's model is applied. Hydrogen atom which contains 1s1, that means single electron. Here Bohr's model is applied. Singly ionized helium atom, that means helium plus helium having the atomic number 2, its electronic configuration is 1s2 but positive charge, that means 2 electron minus 1 electron, it gives rise to 1 electron. Option 2 also exhibited by the Bohr's model. Now let us see the deuterium. Deuterium also containing only 1 electron. So Bohr's model is applied to option 3. Now let us verify the fourth one. This is singly ionized neon. Neon, that means atomic number is 10 electrons minus 1 electron. It becomes 9 electrons. Here Bohr's model is valid only for singly bonded electrons. Here neon positive containing 9 electrons. That's why Bohr's model is not valid for option 4. So our answer is 4 is our correct answer. Now let us discuss the 86th question. In which case a change in entropy is negative? They ask that change in entropy, that means delta S is equal to negative among the 4 options. We know that entropy means the randomness or disorder present in the system. We know that gases have high entropy than liquids. Liquids have high entropy than solids. Solids having the low entropy value. Why? Because they are arranged in an closed packed structure. Gases is highest entropy value. Why? Because there is an increase in randomness or a disorder in the system. Now let us verify the given statements. The first one is evaporation of water. That means liquid when heated, evaporation takes place. Evaporation, evaporation means gas. Here liquid to gas conversion. That means gases have the high randomness. So its value is delta S equal to positive. Why? Because the randomness is increased, liquid converted to gases. Okay. Now let us verify the second statement. Expansion of a gas at constant temperature. Gas is expansion takes place. That's why its change in entropy. That means the randomness increases. Delta S value becomes positive. Now let us verify the third one. Here sublimation of solid to gas. Here solid is converted to gas. That's why here change in entropy will also be increases. Its value becomes delta S equal to positive. Now let us verify the option 4. Here two hydrogens, individual hydrogen gas molecules combines to form the H2 molecule. Here in individual, its randomness is very high. Its randomness or disorder is high. It combines with another mole of hydrogen gas to form hydrogen molecule. In molecule, the randomness is decreased by two hydrogen gas to form the hydrogen gas molecule. Its randomness is decreased. That's why delta S value becomes negative. So according to the question, option 4 satisfies the given question. So our answer is 4 is our correct answer. Now let us discuss 87. Which of the following series of transitions in the spectrum of hydrogen falls under the visible region? Among the four transitions, which series falls under the UV region? Okay, this is a conceptual question. We know that Pascan and bracket series falls under IR, infrared, whereas Lyman series falls under UV region, ultraviolet region. The third one is Balmer series. It falls under the visible region. So according to the concept, visible region falls under Balmer series. So our answer is 2 is our correct answer. Now let us discuss 88th question. The method used to remove the temporary hardness of water. Among the four methods, which method is used to remove the temporary hardness of water? We know that there is two methods to remove the temporary hardness of water. First one is boiling. By boiling, the temporary hardness of water is removed. The second one is Clerk's method. In Clerk's method, to remove the temporary hardness of water, quicklime is added. Okay. Now let us see the methods to remove the permanent hardness of water. The first method is Colgan's method, and the second method is ion exchange, and third one is synthetic resins method. Now let us verify the first option, Colgan's method. We know that Colgan's method is used to remove the permanent hardness of water. So option 1 is eliminated. Ion exchange method is also used to remove the permanent hardness of water. Option 3 is eliminated. Option 4 is also eliminated. Why? Because synthetic resin method is used to remove the permanent hardness of water. The remaining option you have is option 2. Clerk's method is used to remove the temporary hardness of water, and by boiling to remove the temporary hardness of water. Now let us discuss the 89th question. Which one is malachite from the following? Among the four options, The formula of malachite is, we know that malachite is an ore of copper. Its color is green color with formula CuCO3 CuOH twice. So our answer 4 is our correct answer. Discuss 90th question. The correct order of the basic strength of methyl substituted amines in aqueous solution is. Here they are asking that among the given 4 options, which one is the highest basic strength in aqueous solutions? We know that basic nature means the donating ability of an nitrogen. Here lone pairs donating ability. We know that in aqueous solution, 3 factors are affecting the donating nature of amines. The first one is electron donating, that is plus sign inductive effect. The second one is solvation effect, that is hydrogen bonding. The third one is steric hindrance. Firstly, draw the structures of primary, secondary, tertiary amines. Here, CH3 bond NH2 containing 2 lone pair of electrons. This is primary amine. Secondary amine structure is CH3 bond nitrogen bond hydrogen bond CH3. Here presence of 2 lone pair of electrons. This is called secondary amines. The tertiary amine structure is CH3 bond N 2 lone pair of electrons bond CH3 bond CH3. This is called tertiary amines. When you observe the structures of primary, secondary, tertiary amines, we clearly conclude that tertiary amines having the steric hindrance. That's why the lone pair donating ability decreases. By know this point, you can easily eliminate option 2 and option 3. Due to the presence of steric hindrance, the tertiary amines donating of lone pair of electrons decreases. But in primary amines, after donating its lone pairs to others, the positive charge is neutralized by solvation effect, that is hydrogen bonding. So the donating ability of primary is greater than tertiary. When you compare the primary and the secondary is higher donating ability. Why? Because of higher solvation effect. So we conclude that its order is secondary greater than primary greater than tertiary. Now let us verify the given options. Here primary greater than secondary greater than tertiary. Option 4 is also eliminated. Here you have left with option 1. It has secondary greater than primary greater than tertiary. Secondary, primary and tertiary. So option 1 is our correct answer. Now let us discuss 100. Match the list 1 with list 2. In this type of questions, you can easily answer by elimination technique. By using of elimination technique, you can easily answer this type of matching questions. Okay. Here list 1 are reactions and list 2 named reactions. Here are their names. I start with the esterification. Why? Because it is very simple. Its reaction is, esterification means when reaction of alcohol reacted with acid. Now let us suppose RCH2COOH in the presence of H plus to form an ester. That means CH2 C double bond O bond R to form an ester. This is called the esterification. Now let us verify the reactions in list 2. Okay, here C is matches with 4. Now let us verify the given options. C is conformly fixed, that is 4. C is 4. Why? Because it is a very simple reaction. Definitely C is 4. Here C is 4, okay. Here C is 2. You can easily eliminate option 2. Why? Because C damn surely C equal to 4. Why? Because it's an esterification reaction. Now let us see C equal to 1. You can eliminate this option also. And here C equal to 3. No, damn surely C equal to 4. That is esterification. You can eliminate this option also. The only option left with is option A is the correct answer. Now let us verify the remaining options are matches or not. Okay, here equal to 2. That means when you observe this reaction, this is one of the most important named reaction, that when benzene reacted with carbon monoxide in the presence of HCl and anhydrous conditions to form benzaldehyde. This is an Gattermann-Koch reaction. Here A equal to 2. You're absolutely right. Then come to the B. When R bond, C double bond was CH3 in the presence of NaOX. This is called an haloform reaction. To produce the haloforms of CHCl3, CHI3, and so on. These are called the haloform reactions. The last one is Hell-Orhard-Jelinski reaction. D. That means here produces of alpha halogen is produced. That means R bond, here X bond, C double bond O, OH. This reaction is called the Hell-Orhard-Jelinski reaction. Here B becomes 3, absolutely right, and C becomes 4, esterification, and D equal to 1. In this way, you can answer this matching type of questions. Here, simple trick is to go with elimination. Now let us discuss the 9-6 question. From the following pair of ions, which one is not an isoelectronic pair? Now let us firstly try to understand what you meant by isoelectronic. Iso means same, electronic means electrons. That means which pair having the same number of electrons are called isoelectronic pairs. Now let us verify the each and every option. First option, Fe2 positive plus manganese 2 plus. We know that ferrous atomic number 26, its electronic configuration is argon 4s2 3d6. 18 plus 2 20, 20 plus 6 26. Okay, now in a plus 2 form, that means loss of 2 electrons, then its electronic configuration becomes argon 4s0 3d6. That means number of electrons 18 plus 6, it becomes 24 electrons by the loss of 2 electrons. Okay, now let us verify the manganese 2 positive. Manganese atomic number is 25. Its electronic configuration is argon 4s2 3d5. Here also loss of 2 electrons. It becomes argon 4s0 3d5. That means 18 plus 5 becomes 23. Here number of electrons in Fe2 positive is 23. Here number of electrons in Mn2 positive is 20. Here 24. Here 23. Here Fe2 positive Mn2 positive does not obey the isoelectronic. Why? Because their cases they are not have the same electrons. Ferrous 2 plus 2 having the 24 electrons. manganese 2 positive having the 23 electrons. That's why it does not obey the isoelectronic pair. That's why our answer is A is our correct answer. Now let us verify the remaining option also. Second option. Here O2 2 minus Fe minus. You know that atomic number of oxygen is 8. You know that atomic number is equal to number of electrons. That's why its electrons also 8. Here negative charge 2 minus, that means addition of 2 electron to get 8 electron. 8 electron plus 2 electron, it becomes 10 electron. Okay. Fe minus, we know that atomic number of fluorine is 9. That means 9 electron plus negative charge means addition of 1 electron, it becomes 10 electrons. Here O2 2 minus and F minus are isoelectronic pair. Why? Because both having the same number of electrons. Now let us verify the option 3. Here Na positive and magnesium 2 positive. Sodium atomic number is 11. That means its electrons are 11 electrons. Here positive charge means subtraction of 1 electron, it becomes 10 electrons. We know that magnesium atomic number is 12. Then its electrons becomes 12 electrons. Here 2 positive. That means subtraction of 2 electron. 12 minus 2, it becomes 10 electrons. In this case also having the same electrons. That's why it obeys the isoelectronic pair. Now let us verify the option 4. Here manganese 2 positive and Fe 3 positive. We know that ferrous atomic number is 22. Its electronic configuration is argon 4s2 3d6. Now let us see the configuration of Fe3 positive. Its electronic configuration by the loss of 3 electrons, it becomes argon 4s0 3d5. That means argon 18 electron plus 5, it becomes 23 electrons. Now Mn 2 positive. Its electronic configuration is, its atomic number is 25. Its electronic configuration argon 4s2 3d5. By loss of 2 electron, its electronic configuration becomes argon 4s0 3d5. That means 18 electron from argon plus 5 electron, it becomes 23. Fe3 positive having 23 electrons, Mn2 positive is also having 23 electrons. That's why these both are in isoelectronic pair. So option A does not follow the isoelectronic rule. Why? Because here ferrous having the 24 electrons, manganese 2 positive having 23 electrons. So our answer is A is our correct answer. Now let us discuss the 9.5 question. The correct option for the value of vapor pressure of a solution at 45 degrees with benzene to octane in molar ratio. They given the molar ratio 3:2. At 45 degrees, the vapor pressure of benzene is 280 and the vapor pressure of octane is 420 mmHg. Assuming the ideal gas, you have to assume ideal gas. We know that according to Raoult's law, here they are asking the total pressure. That means vapor pressure. P total equal to partial pressure of benzene into its mole fraction of benzene plus partial pressure of octane O into mole fraction of octane. Firstly, calculate the mole fraction of octane and mole fraction of benzene. Here they given the ratio 3:2. It means 3 belongs to benzene, 2 belongs to octane. Here mole fraction of octane is equal to octane, its value is 2 by total 3 plus 2. It becomes 2 by 5. Then mole fraction of benzene equal to 3 by 3 plus 2. It becomes 3 by 5. We know that partial pressure of benzene equal to 280 mmHg, and partial pressure of octane equal to 420 mm of Hg. Now substitute all these values in the given formula. P total is equal to P naught B. Partial pressure of benzene is 280 into mole fraction is 3 by 5 plus partial pressure of octane is 420 into its mole fraction is 2 by 5. 556 the 584 jump, then becomes 56 into 3 plus 84 into 2. 56 into 3 becomes 168 plus 84 into 2, it also becomes 168. By addition of 168 plus 168, the total value is 336. Then total vapor pressure is equal to 336 mm of mercury. So option D is our correct answer. Now let us discuss 97 question. The intermediate compound X. What is the intermediate compound X among the given 4 options? Okay. When you observe this reaction, toluene reaction with chromyl chloride in the presence of CS2 to form an intermediate X, and reaction with H3O positive to form an benzaldehyde. By observing this reaction, this is one of the important named reaction, that is Etard reaction. When toluene, that means methylbenzene, reacted with chromyl chloride in the presence of CS2 to form an complex, that is bond O, bond CH, bond O, Cr, Cl2OH twice. This is a complex formed when an toluene reacts with chromyl chloride in the presence of CS2. This is an intermediate. Which on reaction with H3O positive to form the benzaldehyde. So our answer is 2 is our correct answer. Now let us discuss 9.8. The reagent are in the given sequences of chemical reactions. Here they ask that what is the reagent R. Okay, now let us verify. This is benzene diogenin chloride. When benzene diogenin chloride is reacted with CuCN or KCN to form CN cyano compound Br bond Br bond Br. When this diazonic chloride will react with water to form bond OH, bond Br, bond Br and bond Br. To convert benzene diazonium to this form, you can use certain mild reducing agents. Those are hypophosphorus acid, that means H3PO2, or alcohols CH3, CH2OH. By using of these two, the benzene diazonium chloride is reduced to it's an arene form. Here H3PO2 and CH3, CH2OH themselves oxidize to form phosphorus acid and ethanol, that means CH3, CHO. Itself oxidized to form phosphorus acid and ethanol is produced, ethanol. So our correct answer is 3 is our correct answer. Option 4 is also not satisfied. Why? Because we have to use only H3PO2 and CH3, CH2OH, mild reducing agents. Mild reducing agents will be used to convert benzene diazonium salts to arenes. Now let us discuss 99. The slope of Arrhenius plot lnk versus 1 by T of a first order reaction is. The value of activation energy reaction is. What is the value of activation energy? Okay. Now let us write the given data. Here given that slope is equal to minus 5 into 10 cube. Here they want to calculate the activation energy. Okay, we know that Arrhenius equation. We know that Arrhenius equation is K equal to A into e power minus Ca by RT. Here K is called the rate constant. Here A is called pre-exponential factor. Here A is an activation energy. R is gas constant and T is temperature in Kelvin. Temperature in Kelvin. Now let us apply the log Bayesian. That means ln of K equal to ln of A into e power minus Ca by RT. This is in the form of ln of A into B. It becomes ln of A plus ln of B. Now apply this formula to this equation. Ln of K is equal to ln of A plus ln e power minus Ca by RT. This is also in the form of ln of A power m. Then it becomes m into ln of A. Apply to this equation, you will get ln of K equal to minus Ca by R into 1 by T plus ln A. Here ln of E becomes 1. Slope becomes y equal to m into x plus c. Here m is equal to, that means slope is equal to minus Ca by R. We know that given slope is equal to minus 5 into 10 cube minus Ca by R. Cancel the negative and you will get Ea equal to R into 5 into 10 cube K. Now you can substitute the gas constant value, that is given as 8.314 joule Kelvin inverse mole inverse into 5 into 10 cube Kelvin. Cancel K inverse and K, and you will get activation energy is equal to 41.57 into 10 cube joule mole inverse. Then it is rewrite as activation energy is equal to 41.57 into this 10 cube becomes kilo joule mole inverse. So our correct answer is B is our correct answer. 41.5 kilojoule mole inverse. Now let us see the first question. Okay, 51. The right option for the number of tetrahedral and octahedral voids in the hexagonal primitive unit cell. They ask that the number of tetrahedral voids is equal to question mark and number of octahedral voids question mark. Here they are asking number of tetrahedral and octahedral in hexagonal primitive unit cell. This is a conceptual question, a formula from the textbook, that is the number of tetrahedral voids. The number of tetrahedral voids equal to 2n. The number of octahedral voids equal to n. Here what you meant by n? Here n is equal to effective atoms. For hexagonal means 6. That means n equal to 6 effective atoms. You can substitute 6 in the given formula. You will get the number of tetrahedral voids equal to 2n. Substitute the value n. 2 into 6, that give me 2 into 6, that gives rise to 12. Okay. Now substitute the n value in octahedral voids. The number of octahedral voids is equal to n. That means here n value is equal to 6. The number of tetrahedral voids is equal to 12 and octahedral voids is equal to 6. Let us verify the given options. Okay, 12 is comes first. Okay, there is no other option. 12 comes at first. That's why the remaining options are eliminated. So our option is A is our correct answer. Now let us see the 52nd question. Zirconium having the atomic number 40 and hafnium having the atomic number 72, both having similar atomic and ionic radii because of. Here they are asking the reason. Okay, in this type of questions you go with the verification. Okay, verify the options is the best way to answer this type of questions. The first option, having similar chemical properties. This is not a correct reason because of having similar atomic and ionic radii, but this is one of the consequences of having similar atomic and ionic radii. So option 1 is eliminated. Now let us go to the second option, belonging to the same group. This statement is true. Zirconium and hafnium are belonging to same group. Hafnium comes after 4F series, that means lanthanide. After the lanthanide series, hafnium will comes to the same group. But this is not correct the reason of having similar atomic and ionic radius. So option 2 also eliminated with option 3. Diagonal relationship. This is also the wrong. Why? Because we know that diagonal relationship are generally exhibits the periods of second and third periods. For example, second period lithium, beryllium, boron, carbon, nitrogen are third period elements are sodium, magnesium, aluminum, silicon, phosphorus. This is the diagonal relationship. Lithium, magnesium, and beryllium, aluminum, and boron, silicon, carbon, and phosphorus. Generally, second and third period exhibit the diagonal relationship, but this is not a correct answer for the above question. So option 3 also eliminated. Now let us come to verify the fourth option. Lanthanide contraction. Okay, this is the correct answer for the above statement. Why? Because of due to lanthanide contraction, due to poor shielding of f electrons, the attraction of nucleus and outer electrons increases the size of hafnium. Hafnium size decreases. Why? Because of attractions of nucleus and outermost electron, 4f electrons increases. That's why its size decreases. It becomes equal to zirconium size equal to zirconium. That's why they're having the similar atomic and ionic radii. So our option now to 4 is our correct answer. Now let us see the 55%. Which one among the following is the correct option for the right relation between Cp and Cv for 1 mole of an ideal gas? That means N equal to 1. For 1 mole of an ideal gas, what is the relation between Cp and Cv? Which is also present in intermediate first year question also. For 4 marks, its relation is directly, it's a conceptual question. Cp minus Cv is equal to actually Nr, but here 1 mole that gives rise to N equal to 1, then you will get Cp minus Cv is equal to R. This is a conceptual question. So our option is Cp minus Cv is equal to R. 3 is our correct answer. Now let us see the 56th question. The structures of beryllium chloride in solid state as well as in vapor state are. Okay. This is a conceptual question. We know that beryllium chloride in solid state, they exhibit the polymeric chain structure. The polymeric chain structure of BeCl2 is due to BeCl2 is an electron deficient in nature. That's why BeCl2 exists in polymeric chain in solid state. Its structure is beryllium, chlorine, beryllium, chlorine, and chlorine. Beryllium, chlorine, and chlorine, beryllium, chlorine, and chlorine. This is a polymeric chain structure of beryllium chloride. Now let us see the structure of beryllium chloride in vapor phase. In vapor phase, it exhibited as a dimer. Now let us see the structure of dimer. That means BeCl2, dimer means another mole. that gives rise to 2 moles. Be2Cl4. Its structure is beryllium bond chloride bond beryllium chlorine bond Cl bond Cl. Here you have to keep in mind that when this dimer heats up to 1200 Kelvin temperature, it becomes linear structure. That means beryllium bond Cl bond Cl. This dimer heats at 1200 Kelvin, it becomes a linear structure. Okay. Now let us verify our options. Both in chain, no, eliminated. Chain and dimer. This is our corrections also. Third one, linear in both, no. And dimer and linear. This option also eliminated. Third option is also eliminated. So only option is 2 is our correct answer. Now let us see the 57th question. Tritium, a radioactive isotope of hydrogen, emits which of the following particles? We know that tritium 1, hydrogen 3. This is called the tritium. We know that tritium is the only isotope among the 3 isotopes of hydrogen is the radioactive isotope. Tritium is the radioactive isotope. It has 2 neutrons plus 1 proton. The presence of 2 neutrons plus 1 proton is unstable. It decays to form helium-3 plus beta particles. Beta particles means it is represented as E minus 1 0 or beta minus 1 0. So this beta particle. Now let us see the 64th one. Statement 1. Acid strength increases in the order as given below. Okay. HF, HCl, HBr, HF. Okay, this is the statement 1. Now let us see the statement 2. As the size of the elements fluorine, chlorine, fluorine, chlorine, bromine, iodine down the group increases down the group, the bond strength of HF, HCl decreases, so that acid strength increases. When you compare, it's an fluorine is small size bond to each other, chlorine having the big size, bromine having, by from top to bottom, the size of the fluorine, chlorine, bromine increases, the bond strength, this bond strength is weakens. That's why it easily gives H plus ions when compared to the H of H plus ions. That's why its acid strength order is Hi greater than HBr greater than HCl greater than HF. This indicates the statement 1. So now let us verify the given options. Statement 1 is incorrect. This option is eliminated. Why? Because statement 1 is right according to the statement 2. Both the statement 1 and statement 2 are true. Yes, absolutely. Statement 1 is true and statement 2 is the correct reason for above given statement 1. So 1 and 2 are true. So our answer is 2. Now let us verify the third option. Statement 1 and 2 are false. This is not the correct answer. Eliminated. Now let us verify fourth one. Statement 1 is right, absolutely, but statement 2 is false. No. Statement 2 also right. That's why option 4 is also eliminated. Our correct answer is option 2. That is both statement 1 is right and statement 2 is the correct explanation of statement 1. So both the statements are correct. Now let us see the 63rd question. The incorrect statement among the following is, they ask that out of the 4 options, 1 is incorrect, the remaining 3 are correct answers. In this type of questions, verification is a good method. Now let us verify the each and every option. Now let us verify the first option. Actinoids are highly reactive metals, especially when finely divided. This statement is absolutely true. Why? Because when metals are divided, its surface area increases. So the number of reactants increases. Eventually, it increases the rate of reaction. That's why the first statement is absolutely right. Okay. Let us verify the second option. Actinoid contraction is greater for element to element than lanthanide contraction. This statement is absolutely true. Why? Because you know that actinoid contraction takes place in 5F subcells. It is a poor sealing effect than 4F subcells. That is, lanthanide contraction takes place in 4F subcells. That's why its statement is true. Second one is also, let's verify the option 3. Most of the trivalent lanthanide ions are colorless in the solid state. This statement is absolutely wrong. Why? Because we know that most of the lanthanoids of trivalent solids are colored. Why? Because due to unpaired electrons in F subcell, except lanthanum 3 positive or lutetium 3 positive are colorless, remaining are colored. That's why this statement is wrong statement, incorrect. So our answer is 3 is our correct answer. 3 is our answer. Now let us verify the fourth one also. Lanthanoids are good conductors of heat and electricity. This statement is true. Why? Because due to unpaired electrons, it is paramagnetic in nature. That's why it exhibits as a good conductors of heat and electricity. So fourth option is also right. According to given question, the incorrect statement among the following. Our option 3 is our correct answer. Now let us see the 62nd question. The molar conductivities of sodium chloride, HCl, and sodium acetate are given at infinite solutions are 126.45, 426.16, 91.0 Simon centimeter square mole inverse respectively. Here they ask that what is the molar conductivity of acetic acid at infinite dilution? This question is from physical chemistry. Firstly, write the given data. They given the molar conductivity of sodium chloride is 126.45 Simon centimeter square mole inverse. Okay. The molar conductivity of HCl is 426.16 Simon centimeter square mole inverse. And the molar conductivity of sodium acetate, that gives rise to CH3COONA, that will give rise to 91.0 Simon centimeter square mole inverse. Here they ask that molar conductivity of acetic acid at infinite solution is equal to. Here is the question mark. We have to calculate the molar conductivity at infinite solution of acetic acid. We know that by applying Kohlruff's law, molar conductivity of infinite solution of acetic acid equal to molar conductivity of sodium acetate plus molar conductivity of HCl minus molar conductivity of sodium chloride. Now substitute the above values in the given equation. Here the molar conductivity value of sodium acetate is 91 plus molar conductivity of HCl is 426.16 minus molar conductivity of sodium chloride is 126.45. Here units is Simon centimeter square mole inverse. By solving, you will get 390.71 Simon centimeter square mole inverse. The molar conductivity of acetic acid at infinite dilution equal to 390.71 Simon centimeter square. So our answer is 3 is our correct answer. Now let us see the 17th question. The correct option for the number of body center unit cells in all 14 types of Gravis lattice unit cell. They ask that how many BCCs are present in 14 types of Gravis lattice unit cell. Gravis lattice unit cell. This is a conceptual question. The BCC is present in cubic and tetragonal, and last one is orthorhombic. Orthorhombic. The BCC is present in only 3 among the 14 Gravis lattice structures. So our answer is 3 is our correct answer. Option 1 is the correct. Thank you for watching and all the best. Now let us discuss the 59. Here also match the list with the list 2. Firstly, go with the familiar one. I go with the antacids. I know the drug formula of antacid, which is the cimetidine. That means A matches with 3. Now let us verify the given options. A matches with 3. Here 3 and 4 options matches, that gives rise to A matches with 3. The remaining options you can easily eliminate. Next well-known drug class is antihistamines. I know that the antihistamines, which is a drug molecule of Seldane. So B matches with 4. That is B matches with 4. Here in option 3, B matches with 2. B matches with 2. That's why option C is also eliminated. The only option left with is 4. 4 is our correct answer. There is no need to verify the remaining one. Why? Because 2 are correct. You can easily conclude that 4 is our correct answer.